Welcome to this deep dive where we finally demystify Python classes and build intuition around object-oriented programming. Think of a class as a blueprint, a formal template used for creating individual objects with shared properties and behaviors. In Python, these objects are instances of that blueprint, each holding its own specific data.
Let's imagine we are modeling a fleet of cars. Car would be our class definition.
The fundamental structure begins with the keyword classes, followed by the name, usually in capitalized camel case. The very first method inside almost every class is the special initializer, known as dunder init. This constructor method is automatically called whenever you create a brand new instance of your class. The first parameter for every instance method, including init, must always be self, referring to the instance itself. Inside init, we assign the initial attributes to the instance using self, attribute name followed by the passed-in value. So, for our car, we'd set attributes like color, make, and model when the object is first born. Beyond the initializer, you can define any number of other methods that define the object's capabilities. For instance, a start engine method might change the car's internal state from off to on. Creating an object, or instantiation, looks exactly like calling a function with the class name. If we make myTruck from the car class, we pass in the initial parameters, like red and Ford. Now, myTruck has all the default methods and attributes defined by the car blueprint. You can check its color simply by accessing myTruck color to see its current specific value. Calling a method is just as easy. We use dot notation like myTruck start engine. Crucially, creating a second object, say your sedan, gives it its own independent set of attributes. If your sedan is blue, changing its color won't affect the red truck whatsoever. This isolation of state is precisely why classes are so powerful for managing complexity in software. Now, let's transition to a common beginner mistake: forgetting to include self in a method definition. Without self, the method cannot access the unique instance data, leading to an immediate type error. Another frequent slip-up is confusing class attributes with instance attributes. Class attributes are shared by FID-ally instances and defined directly under the class header outside any method. If you change a class attribute, every single object created from that class sees the update immediately. Instance attributes, set via self, name in init, remain unique to that specific object only. A third mistake involves trying to call an instance method without actually instantiating the class first. You must create the object before you can ask that object to perform an action. Think of inheritance. Next, this allows a new class to adopt and extend the functionality of an existing parent class. A sports car class, for example, can inherit from our general car class and add specialized features. The parent class methods are available automatically, which saves you from writing the same basic code repeatedly. If you need to override a parent's method, you simply redefine it with the same name in the child class. When overriding using super method name lets you run the parent's version before adding your custom logic. This concept of polymorphism allows different objects to respond uniquely to the same method call. We can use special dunder methods to make our objects integrate smoothly with Python's built-in functions. For example, implementing len on your object requires defining the dunder len method. Similarly, using the str function on an instance calls its dunder str method for a readable representation. This allows someone reading your code to instantly understand what your object represents without diving into the source. For real-world context, consider a database connector, class handling connections and queries. Each connection object would store its own unique server address and credentials securely. A method like execute query would use those specific credentials to perform the requested task. If the credentials change, you only update the specific connection object, not the entire system logic. The power here is encapsulating all related logic and data into one self-contained, manageable unit. Remember, classes promote code reuse, make debugging easier, and significantly improve readability. Keep practicing, defining these structures, and experimenting with different attributes and methods. Don't be afraid to deliberately break things to see exactly which errors the interpreter throws at you. By understanding self, init, and instance separation, you are now well on your way to mastering OP in Python. If this explanation clicked for you, please like this video and subscribe for more in-depth programming tutorials. Check out the description below for a link to the full commented code example we used today. Thanks for watching, and happy coding as you build your next great Python application.